Hi, everyone. Thanks for joining us for today's webinar, How to Cure the Model Impact Epidemic, a Path to Sustainable AI in Simple Terms. My name is Scott Barker. I'm with RapidMiner. I'll be your moderator for today's session. I'm joined today by Dr. Ingo Meerswa, the RapidMiner founder, who carries with him 20+ years of data science experience. Ingo's seen this model impact epidemic firsthand for many years. It's a news story that's starting to pop up more and more. We'll talk about that a lot more throughout the course of today's webinar. But Ingo's here to kind of isolate the different variables that influence the epidemic and also talk about how it's been around for a while. Dr. Meerswa will get started in just a few minutes, but first, just want to kick things off with a few quick housekeeping items for those on the line. Today's webinar is being recorded, and you will receive a link to the on-demand version via email within 1 to 2 business days. You are more than free to share that link with colleagues who weren't able to attend today's live session. In fact, we encourage it. Second, if you have any trouble with the audio or video, your best bet is to try logging out and logging back in, again, which will resolve the issue in most cases, the typical IT resolution suggestion. And finally, we'll have Q&A session at the end of today's presentation. I'll be moderating that. Please feel free to ask questions at any time via the questions box on your screen. You can ask questions about the epidemic. You can ask questions about the RapidMiner platform. The world is your oyster there. So with that, I'll pass it over to the star of the show today, Ingo.
Okay, thanks, Scott. Star of the show, right. So glad to be here. This is Ingo talking. And this is really a topic today, which is very close to my own interest in machine learning and data science. As Scott mentioned, I'm doing this for 20 years now, and I love building machine learning models. But what I truly love is actually to get value out of them and use them and making changes. And what happens right now is that this is just not happening at the degree it should be. And people are noticing this. And this goes so far, really, that actually even news sites are talking about this at this point. The point is, we can generate those models, lots of them, but if they're not used, if they're not producing any values, they have no impact whatsoever. So we will see some numbers on the next couple of slides before we or after we have been diving into the news here, where we will show you that we produce millions and billions of models, and only a tiny percentage of them are actually used. So we did some calculations and came up with roughly less than 1% of all models which have been supposed to be in production actually have sustainable impact. And also, by the way, linear regression is machine learning. Mr. Gauss himself would say that. So let's now look into those news for a second here. This is an article we pulled from Forbes, and that is maybe, what is today, October 24th. This is a week old. Look at that. 65% of companies have not seen business gains from their AI investments. Isn't that crazy? We all keep saying this is the most important thing we need to do right now. We keep investing into AI, into machine learning, into data science. We're excited about that. And then still 65% of people say like, well, so far we didn't really see any value coming from that. Oopsie, not really great. And it's in the news, it's in Forbes, but it's also like some of the analyst firms like Gartner here, for example, also from this month. So this is also very recent. They put some research out there about the AI strategy of organizations, and have a look at this first key challenge here. The adoption rate did not meet CIO's expectations in the past year. And I found a third one, and this is a little bit older. This is from July already, okay? So VentureBeat, as often, they have been a little bit faster than maybe some other media outlets here. So they say that only 13% of data science projects, not models, even projects, and we all know that for a single project, you might ending up like generating hundreds and thousands of different models you try out and figure out what is working, and we'll have a look into this in a second. But only 13% of data science projects actually make it into production. All the 87%, the other ones, is lost. And it drives me crazy personally. I mean, again, I put so much work into creating those models, and then nobody is using them. And I mean, there's certainly a couple of data scientists on this call here, and you have to feel the same. If you don't feel that your work is meaningful, what are we doing here? That is not acceptable. And I said that actually also a couple of weeks ago. This is from a press release. And what I said then was, we are discovering an alarming number of businesses that have a really hard time deploying the worthy models into production where they can have an impact. It's getting to the point that we view it as an epidemic. Like any other epidemic, it starts small, like, well, we heard about this a couple of times, and now it's literally everywhere. We produce models, they are not used, they are not actually showing ongoing impact, and that is a huge problem, and it is spreading. So we need to do something about that. And that is really what this webinar here today is about. What are the challenges for models, putting them into production, deploying those models, and managing those models? So there's a lot of different stages for that, and we will go through those stages. We will discuss what's happening, where the problems are, and also how to overcome those challenges. So bear with me when we go actually into the facts now, away from the news. Did somebody say fake news? I like, no, those are real news. I didn't make them up. And we move now over to the actual facts here. So here is our model funnel. All right, so let's view this as a funnel. At the top, those are all the models we are generating and creating. And we can now debate the exact numbers here back and forth, but that's not even that much of a point. I will explain to you where those numbers are coming from in the next couple of slides. But just let's quickly go through those stages once before we go into the details. So the first stage, obviously, before you can put anything into production, is you need to create models, right? I'm talking about machine learning models here. Often they are predictive in nature, supervised models. You want to predict churn, you want to predict that the machine is going to fail, whatever it is you want to solve or optimize here. And we say like roughly 5 billion models are created every year by data scientists. So this is obviously the first stage. And there are challenges with that, and we'll talk about them, but let's use this as a starting point, okay? 5 billion models are created. But then, whenever we create models, not all of those models actually are optimal. So we kick out all the other candidate models, which are not really that great, and we pick a subset of them, which actually could potentially show some impact on the business. And in the second stage, we end up with 50 million models. And again, we go into the details in a second. So first we create the models, then we pick the models which actually could have some impact. But here is now where the fun really begins. In stage 3, out of those models, you still need to do actually a little bit of selling internally in your organization to choose those models for production. And there's a lot of challenges which need to be overcome at this stage. And in fact, as you can see, we believe that only 10% roughly of those models make it into the stage. And then the next stage is like, okay, great. Now the organization made the decision, we want to put them into production, and then half of them actually don't make it over the technical hurdles. So those are models which made it or should go into production, and then only half of them actually go into production. And Gartner recently did another research on that, where they showed that roughly 50% of the models don't make it into over this hurdle. But then the last thing is equally shocking. Now you actually have deployed the models all there, but then you fall short on model management and model operations, and that means that hardly any models are really delivering ongoing value. So we start with billions of models, and then only a small, tiny fraction of those models actually deliver ongoing value, and that is why we call it the epidemic. So now let's go into the details and a little bit more details here. So stage 1 again. This is obviously the starting point. I mean, like, you have a new use case, you have a new problem. What you do in data science, and we call this the no free lunch theorem, you need to try out things. There's no way that you can know in advance which kind of model will work best for your new data set and your new use case. Sometimes people believe, based on prior experiences, that, hey, deep learning was pretty good last week, let's do it again. Yeah, sure, let's try it. But that doesn't have to mean that deep learning also is the best solution for the next problem. And although the no free lunch theorem actually says something slightly different, but it's good to remember it that way. It is really a necessity in data science that you need to try out different models, different parameters for models. We call this hyperparameter optimization, and really find out what is working for your use case. So where's the 5 billion now coming from? Well, let's say there's roughly 1 million data scientists. And there's numbers like all over the place. So there are some people who say like 1 million, some people say up to 3 million, some people even slightly more. Let's be a bit more conservative here, and let's go with 1 million just to make the numbers nice and round. Okay? Let's just agree there's 1 million data scientists globally. And based on our own surveys and among our user base and customers, On average, we found that every data scientist works typically on roughly 5 projects per year. And that might be different for you or in your organization. Some organizations are working on less projects and they are a little bit longer. It might be down to 1 or 2 only. And other people actually are really quick. They go through 10, 15 different projects every year. And that depends also on the complexity of the problems. But on average, let's go with 5. And again, it doesn't really matter if it's 4 or 5, but you get the idea. So 10 million data science, 5 use cases or projects per year. And then whenever you, that's the no free lunch theory now, whenever you actually try to find the best, the optimal model, you need to kiss a lot of frogs to find the prince, okay? So you need to really figure out what is working for your problem here. So based on our auto model, RapidMiner auto model, in case you're familiar with this, it tries a lot of different models, it tries a lot of parameters, and based on the usage data of that part of our product suite, we can actually estimate on average how many model candidates are built per use case by our users. So it's actually more than 1,000, especially if you turn on like feature engineering, automated feature engineering, you can easily generate like 100 or 200,000 models for one particular use case. But again, that's not always necessary. It's not always the case that you do this. So 1,000 is actually more on the lower end. But if you sum it all up, or multiply it all up, you end up with 5 billion. All right, that's our starting point. That's the models which are generated. Now, stage 2. This is where, in my opinion, this is really where good data science happens. So if you're just like creating random models here, obviously, well, that would not be really great. But even if you do something smart, not all models are equal. So you need to evaluate the models. You need to validate the performance on new data sets. You know all of that, I guess. And if not, well, that's what you need to do. So you generate all those model candidates, and then you need to find out what is the 1, sometimes 2 or 3 models which really look like the best, the optimal models, where you believe also in the future those models will perform very well for your use case. Whatever your use case is, to drive cost reduction or revenue gain or risk reduction. So you, from a data science perspective, you try to find the optimal model. All the other models, yeah, they've been necessary on the path to find the optimal one, but they are not the ones which actually will make it into production anyway. But this is just the normal thing. So again, if you start from the 5 billion models, the candidates we have generated in the step before, and we generate 1,000 models candidates per use case, well, only one survives, so we divide that number by 1,000 again. That is where the 50 million is coming from. But this is absolutely normal. This is no free lunch theorem. This is data science as it is. There is nothing really wrong with that. I don't like this kind of waste, and I will definitely talk a little bit about this, how you can try to reduce this kind of waste by having a higher likelihood of finding the optimal model in a quicker way. But this is just data science. This is actually not the waste I'm really upset about. That is what starts now. So now we have 50 million models here. And here is, in my opinion, the first really critical moment. Fantastic. Your data science team sitting in the basement for 3 months and coming up with the fantastic, bestest model ever. And what now? So what does this model really mean? What is like, okay, who is actually making the decision to change the business process using some predictions of this kind of like strange mathematical model some people sitting in some basement came up with? If you're not getting the necessary buy-in from the necessary stakeholders in the organization, this model was just a mathematical exercise. It was actually a waste of resources and nothing else. Because there is no way that somebody will actually change critical business processes by saying like, oh, that's interesting, deep learning, huh? Read about this, fantastic. What is it? AUC rate of 0.85 looks fantastic. Let's change our processes here. Are you kidding me? That never happens. So if all you can do is proving that your model is probably optimal in a data science perspective, you're missing the point completely here, because you won't get the buy-in from the people who need to make the changes in the organization. And there's a lot of other things. So yes, you need to demonstrate the actual business impact. So if you didn't do this, you're doomed already at this point. But even then, there's so many complexities. Like, how is it really put into production? Is this used to inform people? Is this used by automating decision-making? There's a lot of change management and cultural hurdles which need to be overcome. And this is exactly, remember this venture beat statements we talked about earlier? There's only 13% of the projects make it into production. That's exactly this, only 1 out of 10. I think 13% actually high. In my own experience, I have been running, I'm afraid actually, even if I prove business value, sometimes just like, yeah, but we did it this way already for the last, whatever, 20 years. You're not going to change it. Like, no, come on, let's not touch this. There are so many change management issues necessary. I know I talk long about this one stupid slide here, but believe me, here is where you lose most. So, and in fact, 90%. So again, the other 99.9% waste we had before, that's data science. That's no free lunch. There is not a lot we can do about this, but we can improve a little bit. This year is absolutely not necessary. If only 10% of the projects ever make it into production, that is ridiculous. So we need to become better, proving business impacts, and actually making sure that people trust the models, you get the necessary buy-in, you do the right change management, and make sure those models are actually used. Okay? So now you're there. Somebody, a committee maybe, makes the decision, fantastic, let's do it. Let's deploy this model, let's actually put it into production. But here's all of a sudden where IT infrastructure may be necessary, especially if you integrate this into some automated decision-making, or let's say to some website, or however the model is used. You need the infrastructure, you maybe need DevOps resources, you need to get definitely IT involved, and all of that creates additional hurdles. You also need to think about like, okay, great, now the model is in production, is used, but what if it fails? What if the system goes down? Is there any need for failover? How business critical is this really? And so there's a lot of thoughts about that. And then great, you build the model, but how do I know if the model actually still works as expected? So if you need to, after putting months of work into building the model, also need to put easily months or more of work actually setting up the necessary deployment infrastructure, this is the next hurdle. And this is what Gartner said, like this 50% is coming from this Gartner report, that at this stage, there's another 50% which are just getting lost. You made the decision to go into production and you can't get over those hurdles. Again, I'm a little more upset with the 90% loss we had in the previous stage, but this is also absolutely unnecessary, and I will show this to you a little bit later, why I'm so convinced that this is not necessary. And I will show all of this a little bit later, how you can overcome all those hurdles relatively easily. I mean, like, it's not rocket science. You just need to do the right things. All right, so now the final stage. So we have now the decision to go into production. We actually have some, at least rudimentary infrastructure in place to actually do this. But here's the thing, that is not the end of the story. There's a thing like concept drift or concept shift where the world slowly changes. Fantastic if your churn model works for your current customer base, but customers change their behavior over time. Competitors of yours change their behavior. The model which once works is not going to work forever. How are you monitoring this? That the model performance declines maybe over time, that the world has changed. Maybe even if you have been able to demonstrate the business impact at one point of time, maybe the model performance is now so bad that it turns into a negative impact, and the best course of action would be to really sunset this model right away, because otherwise you're going to hurt your business. And trust me, if that happens once, that is the last model you ever will have put into production in this organization. So without ongoing monitoring, there is no ongoing impact and value. And there's only rare cases where machine learning models are really delivering a lot of value in a one-off setting to begin with. So biggest values are really realized if the model is used actually either in an automated fashion or in an ongoing fashion for informing people on a regular basis, really. So if you don't have this in place, then you're kind of doomed as well. And this is actually something I would like to get some feedback from you folks as well, and we will ask you later a little bit, what's your experience? So based on our experience with our own client base, user base, service with this, my own experience as a data scientist, in fact, it's roughly 10% in our opinion of models which really are fully monitored and deliver ongoing value. All the other models are not like that. And this, if you sum all of this up, so forget about the 99.9% from earlier. But even after you found your optimal model in a data science perspective, if you multiply all those percentages up, you're getting down to less than 1% of the models which theoretically from a data science perspective could have an impact on a business and are actually delivering ongoing value. So first you lose like more than 99% because no free lunch theorem, and now out of this remaining tiny fraction, you lose more than 99% again just to overcome cultural and political hurdles, technical deployment issues, and you're not having the right model monitoring in place. And that is the waste which really drives me crazy. And I think this is the main reason for the epidemic here. People made some bad experiences there as well, and then people, I don't know, let's just learn something here, let's move on. And as a data scientist, let's be really honest. We know this is not the most exciting part as well. I mean, just between us here in this little webinar of whatever, hundreds of people here, I mean, creating models is really exciting. But I don't know, like monitoring and managing models, that doesn't sound too exciting, right? But it should be, because it's really, I mean, if you want to do ethical and correct data science, if you want to actually have an impact, if our work is supposed to have a meaning, we should have a high interest there. But again, it's kind of boring, so maybe let's make our life as simple as possible, and that's really what we are going to show next. All right, so here again are the 5 stages: creating models, finding models with impact, choosing models for production, deploying the models, so the actual technical deployment, and then delivering ongoing impact and value. And I'm going through those stages now, and first I will talk about the main challenges in each stage, and then I will actually demonstrate you some ways to overcome those challenges, hopefully inspiring you in your own organization to avoid those challenges, or if you run into them already, that you can get out of them or around them in a more efficient way. Okay, so let's start obviously with stage 1, creating models. So we're talking about the no free lunch theorem already. That is just the normal thing. You generate hundreds, sometimes thousands of models for every new project. And the good news is auto modeling, automated machine learning came a long way in the last couple of years. I mean, we at RapidMiner invested heavily into this as well, because actually, also I personally don't find it too exciting to change some parameters more or less manually, or setting up processes for doing this even in an automated fashion, which you can obviously do with RapidMiner as well. It's kind of like always the same. And this is not what excites me. What I find exciting is being creative, engineering new features, coming up with new ideas, adding new data sets, talking to the business, understanding what's going on, but not the actual technical machine learning modeling work. So AutoML came a long way, reduces the human effort, but there's another aspect to this. If we generate 5 billion models, and I don't know, I didn't do the math here and the energy consumption, but that each model might take minutes, hours sometimes, depending on the data set size. I mean, this is a lot of compute power which we are wasting there as well. So, and again, part of this waste is just data science. There is not a lot we can do. The number crunching is necessary. But if we need to do it, then let's at least make sure that this one surviving champion model, that this model is actually going to show some impact and value. So we better make the use of those resources count here, okay? So this is the first stage, and my main takeaway here: use automated machine learning as much as you can. There's always situations where you want to improve further and use maybe the models which have been generated automatically as a starting point for further manual optimization. You can do that. So of course, at least if you have like a true no black box solution, you can actually see exactly what happens. You can pick it up from there and continue your work. If you have a solution like that, then use it as a starting point. But for most use cases, even the automatically generated model at this point is already far better or good enough in pretty much all use cases to at least have a good baseline solution here right away. All right, use AutoML. And before I show this a little bit in a product demonstration as well, I just want to use both stages here together. So let's just, before we go into the product, let's go into stage 2 first here, because this is the problem. And automated machine learning is also great because you can empower so many more people now to build machine learning models, and I love that. Because this is really what the whole democratization idea is about, to actually say it's not just something only some specialists can do. And again, I don't want to use my brain cells for doing boring hyperparameter optimization or stuff like that, or even all the feature engineering. Like, come on, like, I want to be creative. I want to really have conversations with people. I don't want to just sit there and move parameters around. That's boring. So that's great for data science because it frees us up to really focus on the hard work. But the other aspect is empowering more people. And we sometimes call them citizen data scientists, call them whatever you want to call them. But there is obviously sometimes the problem that if you empower people just to press a couple of buttons and they don't really know what they're doing, that there's the risk that they're doing some rookie data science mistakes. And there's a couple of different mistakes, and I will show you one in the demo in a minute, and how to avoid this also. But I think the most frequent I have seen when it comes to rookie mistakes in data science is actually to use information as input for the model, which is actually not available to you at the point in time you're doing the prediction. Okay, that was a long sentence. Let's break it down. So typically, you create a prediction using a supervised machine learning model, and this prediction has some relevance for a certain point in time. So let's say we build a churn model. That's actually also what we're going to do in our demonstration. And let's say you want to do something. Whenever you know there's a customer who's going to churn soon, you would like to offer them a discount, or put them into some specific marketing campaign, or have your customer success managers reaching out to this person, or whatever it is you want to do. But whatever it is, this activity typically takes time. There's business processes in place and can't be done overnight. I mean, sometimes it can, but often it takes some time. Also, if you wait too long, there's not a lot of value. If the customer already mentally checked out, it's too late at this point in time. So if you're using information now for predicting churn, which is only available 1 hour before the churn event actually happens, there is not enough time to react actually, or prepare really, or be preemptive is maybe a better word. And that is the most frequent thing. And many, sorry to be that blunt, but many business people, they don't think about data science that way. They think like, oh, that's meaningful information. Let's throw it in here. And they're right, it is. But like, you need to think this whole process, like after you created the predictions, you need to also do something. You need to keep this always in mind. And sometimes the right course of action is not to give this information to the model, because the model in reality later on, when it matters, wouldn't have that information as well. So that's a very typical group of rookie mistakes. And I will demonstrate this actually now. But the other way around can also be true. I've been working with data scientists in the basement. That's where I typically sit, in a room without windows and stuff like that. And we've been sitting there like dreaming up how we can really truly impact the business, coming up with a fantastic model, brilliant, 0.999 area under the curve, all like, oh yeah, we're the best. And then we really actually tried to push this into the business. Everybody was like, yeah, so what? We don't care. And that is another thing. Like, if you would have the domain expertise, and many data scientists, they can't know everything, and that's just normal. They solve the wrong problems really. And that is another thing which happens often. So you need this kind of collaboration. Again, this is where automated machine learning can help to some degree, because that also allows the citizen data scientist, maybe somebody in the line of business, to try out themselves if there is something in their data for the use case they actually care about. And if then they say like, hey, here's something interesting, and here, group of data scientists in the basement, can you actually help us out here to make this better? Then they can collaborate on this. So, and there's a couple of other frequent problems. So if I already invested like weeks of work into tuning my model, I keep doing this because I already invested so much. But sometimes it would be better to just like take a step back and really go with a completely different approach. So you run almost kind of like into local optimum, and you're missing the greater picture here and trying something completely different, which would be leading potentially to a much better solution. Another thing I have seen happening too often really, and then obviously this is my favorite. Oh yeah, everybody's using deep learning, so let's use it as well. Yeah, it's true, try it. Again, no free lunch theory, but that doesn't make it the best solution in all cases. So those are typical problems here. What I would like to do now is to show you 3 product demonstrations. So this is the first one, and then when we talk about the other challenges in the stages, we will see 2 more later on, but they all will be around the same use case. And I went with the churn data set and for a telco, just because I think customer churn is something most people can just relate to. So even if your favorite use case is predictive maintenance for machines and sensor data, I guess your organization, if you're producing machines or if you're producing products, you will still have customers, and some of them might churn as well. So it's something we all can relate to some degree. So this is the use case I'm going to do, and I will focus now on the challenges of the first 2 stages and show you how to overcome this with automated machine learning. Mainly the 2 bold challenges here, like how can you reduce the effort and how can you avoid some of those rookie mistakes. All right. Let's shift over here to a RapidMiner studio here, and this is the auto model view, as you can see here at the top. And the same thing, by the way, is also available in a web interface. I just didn't want to take the risk while I'm sharing my screen in this webinar to also have another browser with like some uploading data up and down and whatever, and talking at the same time. So that's why I went with the local version. The web version is as powerful. It's just like It's actually the next version will be even more powerful, which is fantastic. It just actually looks a little bit nicer and modern. And since it's in the web, you can easily distribute it across the organization, so and really empower more people who may not be familiar with RapidMiner Studio here to build machine learning models. So this is the data set. In the first step, you obviously load the data. I'm not going through all the details, but I would like to spend a second here on the data set. As I said, it's a churn case for a telco. Here, the first column is the churn column. So this one here, for example, is somebody we already lost. In all the other cases, they're loyal customers for some time now, so let's not treat them as churn cases at this point, okay? Then we have things like the area code or the phone number. We have things like what kind of plan do they have, and other information like how many minutes and calls and how much do we charge them and stuff like that. All right. You could do segmentation, outlier detection, but actually it's about building a predictive model, and that's what's pre-selected now. Let's predict this column. Let's ignore this step for now, and let's just jump right to the next one, because here is really where you can avoid a lot of those rookie mistakes. So one rookie mistake, for example, would be to use ID-like columns like the phone number. Obviously, the phone number behaves like an ID. That's really a useful feature, because if multiple people would share the same phone numbers, then it's really hard to give them a call, because you would never really know who you end up with. So obviously, phone numbers are IDs. But for machine learning models, and many non-experts just don't know that, using ID-like columns, it just doesn't make a lot of sense, because what is it there you can learn from a column like that? If your phone number contains the digit 3, you're more likely to churn. I mean, who are we kidding here? Of course, that can't be a rule which really has any meaning. So having an ID there can throw machine learning models off. And the best course of action, that's why we turned it red, is to not even use a column like that. And so this is kind of the red columns. But then there's another super interesting thing, is those yellow columns. So green typically means all is good, so just go with them. The yellow columns is typically where you need to understand your business and your processes. Remember, I said before, one of the most common rookie mistakes is to allow the usage of information which is not available to you at the point of time you need to make the prediction. And while the area code is not really changing over time, that's not the case, and the count length is okay as well. The customer service column is interesting. This one, RapidMiner marks yellow, and that means we find it very suspicious. And why do we find it suspicious? Because it is actually too helpful. This is shown by this large orange bar here. It's too helpful to predict the churn column we want to predict. And I don't know really what this customer service column actually means. So I went back to the data people in the organization. They're like, what does this column mean? And they're like, oh yeah, we knew this about churn here. So what we did, whenever we had a churn case, we collected actually the number of customer service representatives calls or contacts we had in the final 2 weeks before the churn actually happens. Wait a second. So that means it's 0 when it's not churned. Yeah. And then it could be any number between 0 and whatever the number is when the churn actually happens. Yeah. Yeah, we shouldn't use that. Because like if we collect this information in the past 2 weeks, like it's always 0 because the churn didn't happen yet. So this column is actually just throwing the models off. So all the models will obviously find this column extremely helpful. If you're complaining to our customer success people like 10 times in the last 2 weeks before you churn, yeah, of course you're out of the door. I mean, that is a huge indicator for a problem. But A, we can't do anything about this. And B, we actually don't have even this information at the moment in time we need to make the prediction. So the right course of action is not to use it. Nice try, we shouldn't use it. So, and this is the kind of thing only you know if you understand your business process. Do you still have enough of time? What does this data actually mean? I mean, we keep talking about how smart machines are, but let's face it, machines are still pretty much dumb. We train models based on data, but there is no model which can tell me based on your business, on your use case, on your column names, what this column actually is about. So only you know. But we can highlight it to you, we can guide you, and we can try to put some spotlight here so you can then make the decision to avoid this kind of rookie mistakes. Another form of rookie mistake would to use the wrong model type. So RapidMiner is suggesting to you what models are probably working well on this data. Well, in this case, just go with all of them. And we also tune the parameters automatically for you, so you don't need to deal with this. We also make some suggestions about automatic like pre-processing or things like feature engineering, feature selection, also feature generation. In this case, the suggestion is not to use it, but that's okay. You can always override this. So let's just go with those settings here. I just kick it off. and then we generate all the models for you. And not explaining all the results to you, that would be a webinar on its own and very exciting, but not for today. While we're waiting those results, what's going to happen is we will get all those different models here, and we'll see in this table how well they perform in a couple of minutes. And again, you're not waiting. Other results already in, like the data we are using or some statistics and stuff like that, but the modeling is still happening. And part of the reason is because we're not just building 8 or 9 different models. In this case, with those settings, actually a couple of hundred, because we try different model types, different types of decision trees, different parameter combinations. And as I mentioned before, if you would actually do automatic feature engineering, you could easily generate hundreds or 200,000 different models in one run. But that would also run potentially a couple of hours, so we're not going to wait for that. So I did this run already before, like yesterday or so. So I'm just loading the results from this previous run, so we don't need to wait, and I can show some of this to you. So here's all the results. As I mentioned, like we generated 223 different models here. And as you can see, for example, for the classification error, all the error rates are somewhere between 9 and whatever, 17%. Actually, the best model here, as also indicated by this little icon, is a gradient boosted tree model, or one of them. So that performed pretty well here. So yeah, you can figure out what kind of model works well. And we will talk a little bit more about the different models. Decision tree actually second best. That's good. So let's have a quick look here. So you can obviously inspect those models. Oh, look at that. The date chart seems to be important. Evening chart, international calls, interesting. International plan, also important. So we will see more about this a little bit later. Now, the one tree, we just, as you can see here. So that is the best model. What else can we do? For example, well, you can, even here is the first step already, that we can prove some business impact. For example, if we are thinking about reaching out to all our customers where we think it's more likely that they're going to churn, if that's all we want to do, just reaching out to them, talking to them, not even offering a discount or anything, then this flip chart here would show us already that we only need to reach out to 10% of our customer base. And within the top 10%, where the model is most sure that that those are actually churn cases, within this 10% of our customer base, we would already cover 50% of our overall churn population. So based on the validation data we have been using. So if you want to bring this to more than 70%, then like, okay, sure, then we need to reach out to 30%. That's, by the way, often a picture. It's almost like this good old Pareto rule, like the 80-20 rule. In order to get to 80% of the results, you need to do 20% of the work. And that's actually some image or picture or pattern we see in machine learning quite often as well, just as a side note. And I also mentioned we generate not one model, but multiple models. So here are the different parameter values here. Blue means lower error rates. So you can see the different parameter combinations RapidMiner tried for this model. We did a grid search in this case, and the best error rates we found so far. And you'll see more about this in the second part of the demo, but let's just go back. So again, as a reminder, this was about reducing the effort, generating those models more efficiently. So if you need to generate all of them, let's generate the right models. So don't try SVMs if they're not going to work on your model set. Use automated machine learning, reduce the manual effort, get some guidance here, avoid the rookie mistakes. That's what this all can do for you to overcome the challenges in the first 2 stages. So now moving on, because again, this is data science. I'm not too worried about that, but I have to admit, now it's where I'm really getting upset. Stage 3 is all about culture and politics and really like, oh, fantastic. Now I have created a model with a certain error rate. I have shown the AOC or whatever it is. But now it's really where I need to get the buy-in. And there's 2 main things you need to overcome here. First of all, many, especially the better machine learning models, are often black box models like deep learning or even gradient boosted trees. Sure, we can understand a single tree, but if I look at 500 different trees and they all are somewhat complex, there's no chance that you really can understand how they interact with each other. So black box models are a problem. So you need to be able to explain the models, and that's hard. There's techniques for doing this, but then also it often requires some communication skills in the data science team, so that is often really a problem. But then the other aspect is just saying, well, we have a 9.4% error rate, and look at our great model explanations here. It is not enough. We also need to calculate the impact this model will have on your business. Without that, you're already lost. If all the argument you have is 9.4% error rate, nobody is putting anything into production. You need to make a statement like, oh, if you would put this model into production within a year, we will save $27 million. Now you get the ears of people. okay? And you need to be able to do this. And by the way, if you make this statement, you better correctly validate your model because it's your neck on the hook. Can I say that in English? Who knows? But you know what I want to say. It's really, you are on the hook, I guess. It's not your neck. Whatever, let's not make an English lesson here for Ingo now. That's not the time. But anyway, so you need to be able to show this business impact because otherwise, I mean, you're actually on the hook anyway because you're generating models which are not going to be used. Not much better. All right. And then you need to start thinking like, well, if you put it into production, how can we make sure that it's going to work in the future? Because again, the world is changing. So people start to have some concerns about like, well, maybe you can't even manage and maintain those models in the future. And then there's the good old, especially if you're not able to prove this impact. Well, we did do this in the same way for 20 years. Like, how can this stupid mathematics be better than my gut? My gut feeling never wrongs me. Yeah. So you have all this kind of communication. You have to have them. We can solve all those problems with technology. I'm not lying to you. Some of those more cultural, political discussions, they require you as a human being to be good at it. But we can at least help you getting the ammunition for having good discussions there. And having the technology can help you with that. And that's exactly what I'm going to do to show you in the next demo. And the major part of this next demonstration is a new functionality we have built here at RapidMiner we call profit-sensitive scoring. So before I demonstrate it in the product, let me quickly explain to you what this is about. So profit-sensitive scoring is the absolute requirement to actually be able to show the business impacts here in the third, highlighted in the third bullet point. And the way how this works is that you basically go through all the combinations of possible predictions and actual values, outcomes, because you always know that, say, I predict churn, and then a year later, I know if the customer actually churned or not. Or they're still with us, great. I predicted loyal, and they're still loyal. Or you predicted loyal, but they actually churned within the year, for example. Then you would be in the top right corner of this matrix here, okay? And for all those combinations, you can assign values. So for example, if you predict loyal and they are actually loyal, well, you're not offering, let's say, you would otherwise offer a 40% discount and the average revenue is 10,000. If you predict loyal and they actually are loyal, you're not offering any discount, but you're also not losing any revenue. So the impact on your revenue is net zero, okay? But if you predict loyal and they are actually churning, you didn't offer any discount, you're going to lose them, and you lose the full 10,000 revenues. And if you predict churn, but they're actually loyal, then you offered a 30% discount, but they would have been staying with you anyway, so the discount was unnecessary, so you just offered 4,000 for nothing. So, and so on. The point really is that there are techniques for that called cost-sensitive learning, meta cost, you can do threshold optimization, but all of those techniques only work for 2 classes in an efficient way. There are techniques which work with more than 2 classes, but then they introduce ensemble learning, and that typically increases the runtime by 10x or more, and also it increases the model complexity. It makes them harder to understand, because if, let's say, instead of having a single decision tree, you now have like an ensemble of 10 decision trees. Or instead of having like 1 gradient boosted trees with 500 models, now you have 10 of them. So it makes it even harder for them to understand, plus training time is longer. So this new profit-sensitive scoring is a technique which allows you to do this in a time-efficient way, so there's no increase in training time, also for cases with more than 2 classes. So let me show to you how you can create those explanations. There's another thing we love is the simulator, which you can use to get the buy-in, and then also the result of profit-sensitive scoring. So since our gradient boosted tree here is actually the best, and it's hard to understand, okay? I mean, you can look into the trees, but that's not really helpful. The first thing I typically do is I show something like the model weights. And those, by the way, are model specific, which is another nice thing we added to RapidMiner recently, that we actually generate model specific weights for all the different weights. So if I, for example, go with the second best decision trees, look on the right side, and now go with the other weights, they are slightly different. Here's day chart, international minutes, and here it's international minutes, evening chart. So different things are important for different models. So here, for example, you see already like international minutes, international plan are important. And you can see this here in the weight. So that's the first thing, because people can say like, well, I didn't know exactly how they impact our business, but we already had the idea that the international plans and the amount of international minutes had something to do with churn. Often people have some hypotheses already, and if they can see it here, that helps them to build trust. And another way of doing this is the simulator here. On the left, you can actually change the input, and on the right, you see how those models will perform. So if, for example, I would change the international plan from no plan to international plan, that has a tiny impact, makes it a little bit more likely to churn, a 14% chance now. But if at the same time also, you see this bar here, international minutes, they're somewhat important now. If I actually now increase those minutes here, you can see if I bring this up here that now this becomes a churn case. So somebody with an international plan and then with 20 minutes or more international minutes, they actually are more likely to churn. And then again, helps you to understand how the model works and if the model behaves like you would expect it. So you can feed in values you know the outcome for into the models here. So this is another way. Then you can actually look into this for a case-by-case basis. So for example, here we predict it's actually churn case. Well, this prediction was wrong, fine, but that's what the prediction was. And it was mainly supported here by this international plan, which was dark green. But it's contradicted. For example, somewhat here by this column, which is slightly red. And definitely there was another one, I guess, here on the right. Well, some here on the right, which are a little bit red as well. So, but this is the strongest red. So strong green means we are supporting this prediction. Strong red means we are contradicting this prediction. For example, like here, we say no, despite the fact that we have an international plan. So this is another way to build some trust in the models. And all those things work together to help you to explain how the model really works. And then the profit-sensitive scoring, this is another thing I love. So you saw gradient boosted trees here is the winner in terms of error rate or whatever you're choosing here, but it is also the winner in terms of business gains. So this is the meaning of this little dollar symbol. So this model on this validation set would actually generate 114,000. While other models, let's go back quickly, for some decision trees only deliver 82%, 82,000. And here the last one, fast large margin, well, it has a high error rate. If you would use this model, you would even lose money versus not doing anything. And here's another, I love those things here. So for example, the third one here, 80,000 in gains, it's the third best in terms of gains, but if you look at the error rates, it actually is not, it's the third one in terms of error rates. So for example, the random forest here has lower error rates, but also lower gains. And here it's so much about like improving error rates, improving AOC, because that all doesn't matter. What you really want to improve for is actually the gains here. So how do we calculate them? Let's actually go back into the gains here. That's here in the performance. So you see the 114,000 here. It's based on this cost matrix we have seen on the slide before. So you take those numbers and you take the entries here in the confusion matrix. This is basically like the different predictions of the model and the actual outcomes. And then there's two default cases. You could, for example, treat everybody as a loyal customer, predicted no churn. Then all the numbers here from the bottom would end up here at the top. And then you can calculate, well, based on that validation data, with those customers, you would lose almost $500,000. Or you would treat everybody as a churn case, give everybody 40% discount. That doesn't seem to be a good idea, and it isn't, in fact, because you would lose even more. I don't know how much, but it's not the best option out of the two defaults. But if you actually go with the model's prediction, then you're losing only customers worth 326,000. So we'll always lose customers. That's to be expected. But the difference between those two, that is the gain the model is delivering. And we will see this again in the third part of the demonstration as well. But let's first talk about deployments. Because now, let's just assume you used all those tools, techniques to really overcome all those political and cultural hurdles. Now you need to actually make sure that those technical hurdles are overcome as well. And here's the thing. A good friend of mine, he has been working for another large data science platform provider with 3 letters, and that could be at least 2 now, so I didn't give away too much. But he kept saying, like, whenever they create a model, and that's, let's say, it takes 6 months, they typically need another 18 months, so 3 times as long to put them actually into production. And everyone was always like, that is crazy. Why should that be the case? Let's speed this up. But there's often like you need to get the infrastructure, DevOps, et cetera, the processes in place. It just takes time. And then often, especially if you're using a more coding-centric approach to data science, that is actually, then you need to do all the coding again for production use. So how can we make this possible to deploy models literally with a couple of clicks and then also get all the proper solutions for model monitoring in place, again, with the same couple of clicks, and make this as simple with as little IT requirements as possible? So I think there's 2 answers to this. One is about using, for example, hosted offers. For that reason, also RapidMiner now started to host all our pieces of the platform as completely managed and hosted offers. So you don't need to set up anything yourself. We just manage everything for you. But the other element is what we call automated model operations. So after you created the model, it should only require you to, like, one click to deploy the model, put it into production, turn everything to web servers, make it integratable. Again, I'm not really sure if that's actually a verse, but I hope you get the idea. And it should be done in an easy way. And then if all the monitoring is done automatically, you should also have the monitoring on the input data for your models done automatically. So for example, if there's concept drift and bias, and we talked about this before, the world always changes. You created the model a year ago, and the world has changed since then. How can you detect that? And that is really an important thing also for doing ethical data science, detecting that potentially you have been choosing a not so optimal subset of data for you building your model, and you have now a biased training sample. That is something you need to be able to detect if the real world just behaves different to what you thought the world will behave. And if you're not doing this right, your model will fail. It won't deliver as good as it should, and it will deteriorate. Oh God, that's a hard word for me to say. It will become worse over time. I think that's what it means, over time. And so you need to be able to see that. So all the model management needs to be done in place as well. So let's have a look into what we call automated model ops, which in particular, in combination with our hosted offerings, makes it really as simple as it can be. So you already saw this big green deploy button, but I'm not clicking on this like right away. Let me show you quickly this new deployments view. First, I'm actually going back to some other place here. So this is what we call the deployments view in RapidMiner. I already have created this churn deployment, and we will use this a little bit later because I already deployed a couple of models here yesterday. But first, let's actually generate a new deployment. So let's call this another one, another churn deployment, whatever. So now we generated the second deployment called another churn, and it's put in place on our infrastructure, and that's literally all you need to do, and now I can start deploying models. So if I go into this deployment here, it actually tells me, like, build some models, get them deployed. Okay, well, good news, I already built a model. This one here, for example, the gradient boosted trees, we like that. We saw before, it's good. So let's just click this deploy button. And that's all you need to do. So now I can change the name, I can actually change the deployment, but in this case, yeah, that's the right one, another churn, let's deploy it there. And now what happens in the background is, you're not just copying the model on the infrastructure, no, but we are also generating scoring processes, web services, monitoring processes. You can set up alerts. You also take a snapshot of all the input data for governance reasons, so you can always prove on what data was this model actually created. If you need to prove out, for example, if you're in Europe for GDPR, how this model was created later on, that there was no bias, that there's no discrimination going on, you need the process how the model was created. That is copied there as well. The data which was used, all the other results, all is bundled together and deployed now at one central position. And since this is the first model which has been deployed, so now we have our first model here, it automatically became the active model. Let's just deploy a second one. I think decision tree was the second best one, so let's just deploy this one here as well. So I said before, the first one becomes the active model. Any additional model now becomes a so-called challenger model, meaning the active model is the model which delivers the predictions to the outside. But we are also generating all predictions and error rates for the challengers. So you can compare if maybe over time one of the challengers performs better than the active one. So with a single click, you can just swap it over to the active, so that the challenger model becomes the new active model. So another second, I guess, and then we should be done here with the second deployment. Let's see. Yep, here we go. So we have two models in this deployment now, the active model from before and the challenger. And as I said before, you can always click on the model. You see the models here again. You see a copy of the input data. You can see all the other models, all the process which has been used to generate those models. So for the rest of the demo, I actually could shift over to the other deployment I already created yesterday, because I already have some scores in there, so I'm not boring you now with actually doing some scoring here, or at least not as much here. So over the last 30 years, you saw that I used the models in this deployment, pretty much the same models we have seen before. It was the top three in our modeling run here. So gradient boosted trees, decision trees, and deep learning. So you see also in this table here that actually what was the error rates we expected to get. And hey, the JBT, it looks really good. It's actually even working slightly better than what we expected. That's good. While the 3D deep learning, a little bit worse, but not really like significantly worse. That's why it's just yellow. So this can be already an early indicator for drift going on. So back to the dashboard. So we see like the number of scores for each day, how many scores we had in total. And those models so far, they delivered 3 million in values, in business gains. And that is really important. A couple of gains here. So you can actually look into more details here in this performance view. I don't have enough time to go through all the details here, but just a couple of highlights briefly. In this performance view, come on now. So in this performance view, you see how many scores again you did for all the different models, which is the currently active model. What is the error rate? So if you focus on the currently active model, you see the orange line here. It is sometimes another model is a little bit better, the decision tree in fact, but most of the days the GBT is best. And then just briefly here again, you see this gain chart here. The purple area, this one here, shows you how much money would you lose to churn over time, the same time frame. So over time, you would actually have been losing the 8.5 million here by always treating everybody as a loyal customer. Thanks to our model now, we actually only lost 5.5 million. So and the difference, which is the orange line here, is the cumulative gain, which is almost 3 million over this course of this time span here. There's the simulator gain, there's the drift calculation, so you can see if there are bigger changes in the data somewhere. For example, VMail plan here, that actually changed because I used the data from the previous year for this VMail, and as you can see, well, the training and discovering data behaves slightly different, especially now we are getting those missings here. What is this about? Well, this is actually a new plan option they introduced by now, but the model never saw it before because it wasn't available in the previous year. So the model treated it as a missing here, and that is starting to throw the model off. Luckily, though, this one here is the same VMail plan, and this one here is just not very important. Here on the x-axis, you see the most important features are here on the right. So, for example, the international minutes here, they behave pretty much the same for training and scoring. Last two things would be the scoring itself. I can score new data in the interest of time. I'm skipping this, but I could just pick another data set right here, upload it, and do some scoring. I can actually calculate alerts here, set up more alerts, so I can get informed and send an email, for example, if the error rates are getting too high, if the drift is getting too high, and all this kind of situations. So as you can see here, now we sent an email to data scientist number 7 here. And then last but not least, I also mentioned we automatically generate all the integration patterns, like set up web servers for you. If I test this here, you can call those web servers from other applications, done automatically as part of your business processes. You can connect this to Salesforce, Tableau, whatever you want to connect this to, you can do all of that. So that is the demo part. I would like to wrap this now with like really coming back to the epidemic and why all those challenges and overcoming them is so important. Because otherwise, if you're not fighting the epidemic now, if you're not seeing the challenges, if you keep failing with putting models into production, things will get worse from here. Especially if you're, I mean, the political, cultural challenges is one thing, but the technical, the deployment challenges and the model management challenges, you saw how easy it is. Single click. But if you're not doing this right in those later stages, your models will fail over time. So if you don't have model ops in place, model operations, so then you will run into situations where the models actually will no longer deliver value or sometimes even negative value. So it's hard to sustain the impact. That will lead to bad experiences. One bad experience alone can be enough to get less buy-in from the rest of the organization. That means if you have less buy-in, you build less models, and guess what? Then you will use the fact that you build less models as an excuse that you don't need model operations, and that's where the spiral goes really downwards. Don't allow that to happen. I've seen and working with organizations where this happened over time, and it's a shame because the impact of machine learning, AI, surely on business, but also for the greater good of this world, can be massive. And we should not get led to waste by actually running into this epidemic and let this happen. So do me this favor and let's fight this again together. And that's it. Let's open up for questions.
All right. Thanks, Ingo. So we've got just about a minute. So, but there was one. No, good. There was one audience question that I did promise that we would get to. And then if you guys want to hang on the line for one or two more, we can do that as well. But obviously, as I mentioned before, we'll be sending a recorded version of the presentation within the next few business days via email. So if you have to drop off, then you can watch the end of this recording when you get that in your inbox. And then just one other thing, we are going to be sending a survey around with some questions, not just about the webinar itself, but also trying to gather some data and some intel on the epidemic and what you guys are seeing and experiencing in your own environment. So the question I wanted to get to that I promised we would get to, I really like the drifting part, so the drift management. Is it possible to deploy existing models without using the auto model functionality? And that's from Andreas, if I may be pronouncing that correct.
No, well, I could go into a lot of technical details right now, or let's say not yet. We're definitely thinking about this. Every model which goes into production consists of multiple assets or artifacts, so to say. It's more than just the predictive model itself. There's also like ways how to handle unknown data or new data values. So, for example, this V plan we have seen before. What are we doing with the situations like that? So it would be easy to also allow to do this for like just the predictive model itself, but there is more to actually getting to robust models than just the model. And in fact, it's a total set of 8 artifacts. I'm not going to into the details which they are, but I can show you at least the scoring process, because everything in RapidMiner is always well, very transparent. So if I go actually into this repository here, you can even see the scoring process, and you could build a process or change those processes if you want to yourself. You don't recommend to do that, but you could. And as you can see, only one of those artifacts, actually the predictive model, and all the rest are some statistics, feature sets, text modeling, encoding models, handling missing values, unknown values, and so on. And then there's some general pre-processing happening here as well. So this is the overall scoring process. It's actually fascinating to have a look into this if you're interested in those details. But right now there is no one-click solution to do this with your manually built models. So one thing I didn't show, maybe just for the benefit for everybody else, is that you can also build manually models by designing those processes yourself. And this is exactly the same AutoModel is doing. So you can always open this process here and do this. And that is maybe a half answer. Sorry, I can't stop talking. But you could, for example, use AutoModel, get started with that, then tune the AutoModel processes, generate the same artifacts, deploy the process from AutoModel, and then override those 7 or 8 artifacts I mentioned before with the ones you generated with the optimized process. So I would say yes, but you can with restrictions. But we are definitely thinking about like supporting manually built processes and models in the future as well.
All right, we're getting a lot more questions, and I can tell you right now we won't get to all of them on the webinar.
I mean,
but we will follow up. Yeah, we'll follow up with everyone who answered a question or asked a question. We'll follow up with you offline. There's a couple more I want to get to, and one is, and this is something you actually glossed over towards the end because you knew you were running out of time, Ingo. But can you explain the supported types for alerts?
Yeah. Let's see. Yeah, this is really what model operations is about, because I mentioned right at the beginning of the webinar that this is actually not that exciting work. So the exciting work is the model building. Putting models into production, monitoring them is not exciting. Definitely what's also not exciting is to check every day, hey, is this error rate still where it should be? I mean, like, who wants to do that? So it's pretty simple. You click here, creating new alerts, and then there's what we call triggers here, and let me just open it up. So you could, for example, set a threshold for the average error rate. We saw that. Then sometimes models can get slower over time. It shouldn't happen, but it does happen from time to time. So you can actually set alerts for that. And then for example, here, another one is less scores. That actually happened in this deployment here. Over time, we score less and less data. And that can be sometimes an indicator that the integration no longer works as expected. If an active model becomes worse than a challenger, so you should probably want to know about that, or if the drift gets larger. So if you folks have better or other ideas we could add as additional triggers, we would love to hear about them, but those are the ones we see most often as a requirement in the field. And then you just define those thresholds. You can say, like, hey, let's say, for example, if the active model was worse than the challenger for the last week, the data of the last week, and I check this every day, then, for example, send an email or do something. That's how we would set it up, and those are the other alerts.
Cool. I'm glad we got that question, because that was a part of the platform that you did have to kind of speed through.
Yep.
So we've got a lot of people still on the line and gotten some good feedback, so we'll hang on for one more question, and then we'll be respectful of the rest of your day and cut the webinar off. How are the error rates in the deployment view calculated? You would need the actual outcome as well, question mark?
Yeah, right. And that's actually two parts. Yes. And this is, by the way, a thing I think is absolutely fantastic about the way how we did it. So you can really actually close what we call the feedback loop. Because some other solutions I've seen in the past, what is happening there is they kind of like use the same validation set you have been using while you've been building the model, and then you just like apply the models against those. What's the point? I mean, like, it's the same validation set over and over again. What are you expecting to see? A different outcome every time? That doesn't make sense. So, and then the different outcomes, like, oh, I could retrain the model. Sure, you could do that, but again, it doesn't capture the nature of that the world is changing. So those error rates here, where are they coming from? And the way we're doing this, I didn't show you the scoring either, but when you do the scoring, there's two actions here. There's you score the data, and you can define actions. So let's actually go quickly through both parts here. If you score the data, let's just wait, I can actually auto-model demo. I think I have some, yeah, this one here, for example. If you score data, you could, for example, you see like RapidMiner detects like here's a couple of columns which have not been used by the models, but one of the columns could actually be the actual churn outcome. It doesn't even need to be called churn. RapidMiner would still pick it up from the values and the distribution of values that this is the churn column. So if you would provide a column like that as part of the scoring already, then if you do this bulk scoring here, then you take the error rate from that. But sometimes you don't have that either, and then you can just say like, well, because typically you make the predictions and then 6 months later you know the outcome. And then let's just go with the data set where I do have it, like for example, this same data set really. Then here, for example, I could say like, well, for every phone number, which I then treat as an ID, I would actually now know the outcome. So I upload those outcomes here. And then we can actually, in retrospective, close the feedback loop and calculate how well did the model actually do now that we know the outcome. So this is one way of doing this. And here also, like here is a web service for creating the scoring. But look at this one here on the right. There is also a web service for defining the actual outcome. So if you automate the decision making, let's say you connect this to Salesforce, you make churn prediction, and then the customer actually churns, or they didn't after a year, you can integrate this web service for closing this feedback loop automatically, so nobody needs to upload anything. So there's those two major ways how we can close this feedback loop and define the actual outcomes, so we can calculate actual error rates and not just like some, I don't know, baloney.
More predictions.
Yeah.
Yeah.
Exactly.
Awesome. Well, hey, I want to thank everyone wholeheartedly for staying on the line. We've got a good number of people still on here, so thank you very much for staying. Sorry for any questions that we did not get to. As I mentioned, we'll reply offline to you. And just as a reminder, that survey I mentioned before will pop up after we close the webinar. So would love it if you could take a few more minutes and reply. But thanks for the time you've given us today, and hopefully you found the talk informative and insightful. And have a great rest of your day.